Tomorrow is, I already said that, word search day, so make sure you come prepared for that. Today is 11:21. You will not turn them in. You will not turn them in. So 11:21, that is today. And today we start talking about something that we'll be talking about for quite some time. And that is graphs of linear equations. I don't remember how I phrased it earlier. Yeah, I don't know. That's weird. Let's call it graphing lines. How's that? So yeah, here we go, right? This is all we'll be doing here for a little while. So the slope, you got to get the slope out of the way. So we do slope first because none of this makes sense if you don't understand slope. But there are three formats for linear equations that you guys will learn in my class, or that I will try very, very hard to teach you. And two of them we're not going to talk about yet, but I'll tell you what they're called. You don't have to write this down. The first one is called standard form. That's like when x and y are on the same side of the equal sign. So if it said like 3x plus 2y equals 10, that's called standard form. Another one is called point slope form. That one is super useful. And it's a little bit harder to just speak y minus y1 equals m times x minus x1. It sounds really weird. The third one is the one we're going to talk about here for a couple of days. And it's the one that if you're a ninth grader, you're very, very familiar with from your 8th grade math class. And it's called Slope-Intercept. And you may not recognize it, but I'm guessing once I put the format of it up here on the board that you'll go, oh yeah, I remember this. Anyone know it by chance? What in the world is Slope-Intercept? It's this. Is it ringing any bells? I feel like in Mr. Manlove's 8th grade, you guys do quite a bit with Slope-Intercept and y equals mx plus b. And I like when I put the slope formula up last week, there was some nodding of heads and people, oh yeah, we've done this before. We've done that before. This might look familiar to you when we're done. So I'm going to bring up Desmos here in a little bit. I'm going to let the computer kind of try to get a picture stuck in your head. But the first thing I want to tell you is that y and x are not, they're going to be like the players in the game. So we're not going to mess with them right now. I'm going to talk to you though about these other two guys, M and B. You know this if you were here last week. What is M? It is very good. So the number that's attached to x is your slope number. And that's the number that determines the structural sort of nature of the line. Does it go uphill? Does it go downhill? Is it super wimpy like bunny hill ski slope, or is it like mega steep? That all of that information comes from the number that's attached to x. That's called the slope. And then the b, do you guys remember this guy? Very good. Yes. And you know what? I like the way you said it better than what I said. I'm going to write it this way because I kind of have to. We have to call it this, but it's called the y-intercept. But like Irene said, it's the number or place where it goes through the y-axis. So I used this analogy earlier, and then I'll bring up Desmos to show you what I'm clumsily trying to explain to you. So imagine you were at home and you had a nail and a hammer and a yardstick, and you went up to the wall and you went right through the center of the yardstick and you punked a nail into the wall right through the center of the yardstick. You agree that that point would be fixed, right? But then if someone took your yardstick and started, smacking on it, it could tilt, right? It could tilt up, it could tilt down, but that one point in the middle stays fixed. You agree? So I'm going to show you over here in Desmos what this looks like. Oh, bless you. Was that a sneeze? Bless you. I wasn't sure at first. Now I'm sure. So here's a line that I did earlier, and I went over to Desmos and I typed in y equals ax plus 2. And the reason I wanted to do it this way for our first line together was I want you to see what it looks like. I'm going to hit this animate button here in just a second, but I want you to see, first off, do you see where the line got hooked to the y-axis, like Irene said, 2 down from 0. So there's a hooking point right here where I'm moving my mouse. Now, as I hit the animate button, I want you to watch what happens. It's really not all that interesting, but I want this picture to get stuck in your head. Just kind of sit and stare at it for 20 seconds or so. And the idea here is that what I have in Desmos is called a slider. It's just always changing the value of the number that's attached to X. And so if I were just to pause it at any point in time, if I was just like, okay, here we go, boom, there, I did it. You can see the characteristics of the line that I want you to see. The y-intercept, the point where it goes through the y-axis, is down 2. If you sat and watched that for 10 seconds, it never moved. That was the nail in the wall as the line tilted. What would the slope of this line be as it's written? 2.92. And that means basically that I'm going up 2.92 steps for every one that I go to the right. And you can see that reflected in the graph. And if I hit play again and I keep going, what's the slope of that line? Negative 0.8. That means it's going down 8/10 of a step for every one to the right. That's what slope has always been a measure of, is how much vertical change do you undergo for every unit of horizontal change. Reanimate it again. Slope is now -4. So you can see as the slope gets further away from 0, obviously the line gets substantially more steep. What will change if I change this -2 at the end? I'm going to highlight it for you. What changes if I change that into like a +3? Your hooking point goes up. So if I change that to +3, the hooking point is now up at 3, but the line behaves the same way. So as the slope is changing, it's swiveling and tilting, but that one nail in the wall remains fixed, and that's the key. Okay? So I have 2 things that I want to practice with you today, and I'm just going to let that play for a second here. Just want you to really just get that idea that that one point in the middle is non-negotiable. But the 2 goals for the day are, 1, I want to be able to give you an equation and have you graph it. And 2, I want to be able to give you a graph and have you tell me what the equation of the line is. That should take about 7 or 8 more minutes, and then we'll get going on your worksheet with the awesome jokes. Got it? Cool. I didn't. I was just stretching. I had a kink in my elbow. Sorry. Good. It's all interconnected. It's all interconnected. You know, the elbow's connected to the neck bone. The neck bone's connected to the funny bone. The funny bone's connected to the toe bone. It's totally legit. Thank you. It's the nicest thing anyone said to me all day. Yeah. So we're gonna graph some lines here. So we have an x-axis and we have a y-axis, and I just want you to, before you leave today, I want you to understand that this is just not something that we should ever mess up. So here it goes. On the easy scale of 1 to 10, I hope you agree here in a minute or so that this is way up high. This is like a 9.8. So here we go. I'm going to give you an equation. Y equals 1/2 of x minus 4. And by the way, there's another way to teach how to graph, and that's called using a table, where you make a table, a split table, and you pick a bunch of X numbers that you like, you put them in, you do all the math, and then it gives you back Ys. We'll do that some other day. Today, we're just going to take this nice, easy route. So no like math necessary here. Where would this graph, what would be the first thing you'd say you know about this graph? It starts at you both said great things, but I'm always going to start with the hooking point. And in this case, the hooking point is the nail in the wall. It's that point that was fixed on my Desmos graph as it swiveled. And that is a -4. So when we say, where does the graph start? We'll always say down 4. So we're going to go down 4 and put our first point there. That is the nail in the wall. Now from here, if I said, hey, all of you graph a line through this point, I should get different lines from all of you. But as soon as we know a slope, then we should all get the same line. And the slope is determined by that number that's in front of the x. How do we interpret a 1/2 slope? Now, you may never say the word over, so you may use the words up, down, right, and left. What do we do? Couldn't have said it better myself. So from the hooking point, I'm going to go up one, right two, ping a point. Up one, right two, up one, right two. What if, let me ask you this, could I have gone down one? Of course. The only difference being I would then have to go left two. And what's important about this is like I've answered so many questions over the years about, well, I don't know if I should go right or left. And I, I, I welcome questions, but I kind of hate that one because if you know that number in front of X is positive, then you know your line has to go uphill. So any question you ever have about, well, I'm confused. I went down two and I don't know which way to go. I don't really get that question. Like, I don't understand. If you go right three and put a dot, look at the line. If it doesn't match, well, then you were supposed to go left three, right? So make sure that your line logically tilts the way the equation says that it should. So when you go to graph a line, then you just simply grab your ruler and make a line. And of course, my line right now would get me yelled at. I need to put arrowheads on the ends. Got it. Good. Let's do another one. How about y equals negative 4/3 of x? And no, I did not forget to write the last part of this. I just chose to. So what is my starting point, my hooking point? It says it's at zero. It's at the origin, right? What we're used to is at the end of the problem right here, you're used to there being a thing like, you want me to go up three? If it makes you feel better, you can always add a +0. But of course, then that just means that the starting point is simply don't go anywhere. What is the slope, logically, positive or negative? It's definitely negative. So if your line does not go downhill like this when you're done, you should feel upset about that. Like, what am I doing? Right. So we know the line has to go downhill. So let's say that I, since it's a free country, bless you, that I choose to leave from my hooking point and I go up 1, 2, 3, 4. So you can see where I'm kind of wiggling my pen around. Which way do I have to turn? I have to go left three. And if I had chosen to go down 1, 2, 3, 4, then I would have to go right three. Again, the idea is that the line just simply has to match logically uphill, downhill. I should never have to talk about that again, but it will come up. The slope of the yellow line is definitely negative, right? Oh, certainly not. No, we were done with the red one. Let's go again. Green equation. Where would we start at? We would start by going up one. And if you listen, I'm going to bug you about that. And you can test it if you want to, if you like that kind of thing. But I will continue to remind you that when I ask where do we start, you need to use one of the words up or down. Because in this line of work, when I let kids get away with that, oh, let's just start the graph at one, kids start the graph there where that green dot is. Not a lot, but some, and that's too many. One's too many. So when we talk about where do we start our graph, let's form a habit today of always saying up or down. So in this case, we agree we're going to start our graph by going up one. So we're going to go up one and we're going to place a point, and that's that. What is the slope? Yeah, and that's really the key is to identify that slope of 3, it doesn't look like a fraction, but you know that it is. It's a 3/1, right? And so when we track our points from our hooking point, we're going to go up 1, 2, 3, right 1, up 1, 2, 3, right 1, or conversely, down 3 and left 1. Any issues with that? Okay. A couple things before I move into the second half. At some point, you will see horizontal and vertical lines, and it won't be today, but I'm just going to go ahead and have this just kind of initial discussion right now. Thank you. We don't need that. So here's just a quick peek at this. Not all equations have both x and y in them, and so say I took a line like this red one. and I asked you to write me the equation of the line. It just before we get into again the other stuff, look at all the points on this line. And there's infinitely many of them, but what's, I'll say the comical one so you don't have to. Like if I said what do they all have in common? Oh, they're all round, they're all red. I get that. What is a mathematical characteristic that all of the red points share? It's a mathematical characteristic, Sutter.
They're lying.
What is that? I agree. And this is a thing that I hope someday you memorize, not if, but when you get horizontal and vertical lines backwards. Every point on that line has one thing in common. One. And it's that every one of them has a y coordinate of 4. So you're going to get really used to writing equations of lines that have x's and y's. These don't. They only have one, because there's only one constraint that has to be true. If your y is a certain number, you're fixed at a certain height. What do you think could be said about this yellow line? I mean, if I said to write the equation of that yellow line, what's true? If I just go and I make a bunch of points and I go boom, 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 and I just keep plotting points on that line, you tell me what's one thing that all the yellow points have in common? Yes. And what is it? Yes. And so if someone comes up to me and says, write me the equation of that yellow line, I think this is not an if, this is a when. I get verticals and horizontals backwards. I go back and remember what my teacher said. Pick a bunch of points on the line and ask yourself, what do they have in common? And like Kennedy said, the one thing that they all have in common is that they all share the same x. And in this case, it is exactly -3. So as we go into this next part of the lesson, we're going to be graphing crooked lines, oblique, tilty lines with all that stuff. But bear in mind that these guys are out there and they're going to make you want to say them backwards because the X ones look like a Y axis. What? And the Y ones look like an X axis. And we'll talk more about that, but I wanted to get that out there for now. So real quick, I'm going to graph a couple of lines and you guys are going to help me come up with the equations of the lines. And then we'll be done and we'll do some homework together. Get you started. I got to graph some axes. I need to save this. I need to find a way to save this in my, so I could just click and say, bring me a graph. Go. Kind of a bad example there. Let me see if I can grab it and move it just a little bit for you. I don't know if it wants to be moved. So let's say I gave you this line and I said, I want you to write me the equation of the line. Don't forget the idea for today. I know I talk a lot. Remember this. The idea for today is you need two things. You need the hooking point and you need the slope. So to begin with, what's the y-intercept of this equation? Up 2. Very good. In this case, that means that my equation, when I say, please write me the equation of this line, I know it's going to look like this. The +2 at the end is locked in. And the other thing I'm going to need is the slope. What do you think the slope of this line is? So this will happen because I know that I'm powerless to stop it. But you should look at that answer and you should want to punch a baby. I know I say that and you should never punch a baby, but that's to make a point. What's wrong with my equation? The slope has to go downhill. This happen again. All the time does this happen because we get so wrapped up in the ratio and we're so proud of ourselves because we're like, oh, I see it. There's a 1 and a 2 and a 1 and a 2, and I see that slope of 1/2, but I forget that it's got to be -1/2. All right. Let's do another one. First thing that catches your eye about this line, what is it? Positive slope. I agree. So we know the number that's attached to x is going to be a positive. What's something else that catches your eye? Thank you. I think more people saw that and just didn't want to talk to me. I appreciate you vocalizing that. The graph goes through the y-axis at down three. If I haven't done a good job of explaining this, let me try again. That point's really important. The y-intercept is part of your equation. Where the graph crosses the y-axis is huge. So I know now if it crosses the y-axis at -3 that my equation for sure looks like that. All that's left for me to figure out is what's the tilt. Can you see the tilt, the slope from my line? I see tons of lattice points, by the way. You should as well. I see one there, 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 there. So if this was a last week worksheet and we were just practicing slope, you've got a boatload of points from which to choose. What overall is the continuous rise, run pattern? What is it? Yes, up one, right one, up one, right one, up one, right one. Also known as 1/1 is 1, which means I could just write my equation like that. There's not even a 1 in front of the x, but I know that it's actually there. Let me give you another one. I forgot to switch tools. What's our starting point? At 0, the origin. And so I wouldn't, quite frankly, even probably write it. You could if it would make you feel better, but I could just write y equals, knowing full well that there is a +0 at the end. I elect not to write it. So all that's left is the slope, positive or negative? Positive for sure, because it goes uphill. And then I'm just going to count out a rise and a run, and it looks like it's 2 for every 3, 2 for every 3, 2 for every 3, so on and so forth. So the slope is 2/3. Done. Got it? So I'm probably just going to keep recording in case anyone's interested. And then I'm going to hand out today's, I'm going to pause this. Don't let me forget to unpause it. And I'm going to hand out today's worksheet and I'll bring it up on the board and we can actually just do a few problems together. Sound good? So I have this up here because I thought I know it would help me as a student to do some problems together. So make sure I'm recording. Yay, good. So I'm going to graph a line. And so the very first problem says write the equation of the line AB. So what I'm going to do is I'm going to graph the line that actually goes through the points AB. And that's what you're going to be doing right now as well, is you're going to grab a ruler. My color choice could not be any worse, but you know what? Let's just go with it. So I've got myself a line, and now what I need to do is in that little blank next to the problem, I need to write the equation. And if you haven't participated yet by speaking, I hope it's for the right reasons and that you just don't feel like talking. But these answers are essential. What's the first thing you notice about the line? Slope is positive. So I know for sure whatever number I attach to x, it better not be negative. And what's the second thing that catches my eye? Where does it start at? It starts at down 3. And so we know for sure that our equation is going to say y equals, I'm sorry, I can't, I said I was going to commit to this. I cannot. That's a terrible color. We know the line is going to start with, or the equation is going to start with y equals, and we know it's going to end with a -3. Now I got to go count the slope. And the slope is always a matter of a ratio of rise and run. And I feel like if you count with me, I mean, you see that these things I'm circling in red, those are also lattice points, right? And so I don't have to go all the way from point A to point B. Like there's nothing wrong if you want to go all the way from A and then across to B, that's fine. That is a 6 and a 3. Or you could stay a little bit more local and just do a 2 and a 1. Either way, what is the slope of the line? It is just 2, right? And if you put 2/1, it's not, I understand your heart's in the right place, but you won't find that at the bottom of the page. So we're going to clean that up and just put 2x. To be clear, x is not part of the slope. X will not be part of your slope until you take a class called calculus. X is our input. 2 is the slope. Let's do another one. Second one says to do the line CB. So I'm going to erase some stuff up here. And so for the line CB, I see the point C and I see the point B. And remember what I've said, your lines should be not little wimpy sticks, right? They should be fully through your grid, poking out essentially both ends. So what catches your eye? Positive slope, positive slope. And where does it start at? At up 1. And so we know our equation is going to say y equals, and we know at the end of it, it's going to say +1. That starting point is always like how you end it. No x attached, it's just a starting constant. And what's the slope? Yeah, and again, the 2/3 is the slope, not the x. And so when I say what's the slope, it's just 2/3. And then we attach it to an x like that. Got it? Easy peasy, you think? Let's take a look at the line DE. I'm going to zoom out just a little bit for this one. So for the line DE, I'm going to switch to red here. You should all have a line that looks like this. Remember, all the way through, arrowheads on both sides, get in the habit. What catches your eye? Negative slope. So if the number I don't attach to my x is negative, I should probably give myself a timeout or something. Where does the graph begin its journey on the y-axis? At -4. So again, I know that my equation will say y equals, and then there's going to be something blah, 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 -4. And again, last week existed so that we could do this week. And what is the slope of the line? Do you see it? So you want me to put y equals 2x minus 4? Thank you. -2x minus 4. So I know I heard a couple people over here say the number 2, and your heart is totally right in the right place when you're saying that. You just have to, again, always be aware that it's -2 because the ratio is indeed 2 to 1, 2 to 1, 2 to 1, 2 to 1, but it is downhill. So, do you guys have any questions about that page? All right, let's flip it over and look at the other side, please. So on this page, you are given equations and asked to graph them. So this should be a simple task. On the very first problem, where will I begin my journey? At up 1. Very good. And again, don't just say 1, up 1. We want to be really clear. Up 1. And what is the slope of the line? Up 2, right 3. Thank you for catching yourself and not saying over. Good job. Up 2, right 3. Now, I don't like having only 2 points on my graph, but I'm out of room. I can't go up 2 and right 3. So what else could I do? I could go down 2, go back to your hook point, and go down 2, and then which way? Left 3. I'm still making the same proper uphill tilt of 2/3. I just used a couple negative movements to make it happen. And then again, as always, grab your ruler and connect the dots with a nice straight line. And the idea on this page is that the line will extend through a letter on the outside of the grid. In this case, you can see it slashes right through the letter O. So we're going to go to the bottom of the page, and where it says problem number 1, we're going to put the letter O. Do you guys have any questions for me? Do you think you can knock this out? All right.